Hello and welcome to Algebra 2 tutorial. In this video we're going to be taking our polynomials and sketching a graph of them. And so in order to do this we have to go back a little ways and first take a look at end behavior again, because that's one of the most important aspects of a polynomial's graph. So this is pretty basic, but it's a good review for us. So if your polynomial has an odd degree, so that's any cubic or fifth degree, etc., etc., anything where the exponent is odd. So remember what that looks like. I'll just draw the parent function of x cubed. It starts bottom left, flattens out, and then top right. And so these arrows right here are the end behavior. All right, so an odd degree, bottom left, top right. Now, unless that can be switched, if you have something like a negative cubic, well, now it just gets flipped. And so it starts up here, flattens out, and then goes down. And so now you can see the end behavior has been flipped. Now, when we do more and more complicated polynomials, yes, in the middle, there will be some waves. And the same thing over here, there could be some waves here, but end behavior, the arrows on the end is the same. So you can see they go diagonally. You just got to remember which one is positive and which one is negative. All right, even degrees. So these are our x squareds or x to the fourth. Ooh, what happened there? My bad. X to the fourth. These, the end behaviors go in the same direction. So you have your parabola that goes up. And yes, there might be some waves in the middle, but your end behavior, both arrows are pointing up. Now, unless you have a negative in the front. And of course, all that does is take this parabola shape and flip it upside down. And so now our end behavior are both going down. So that can flip your graph upside down. So that's one of the first things we're going to look at as we do our graphs of polynomial functions. So once we have the end behavior sorted out, we want to move on to the x-intercepts. That's the next really important characteristic of your graph. So for these, I'm almost always going to give them to you in factored form just because it's easier and you can see your x-intercepts. So we know this graph has to go through x equals 3, it has to go through x equals 5, and it has to go through x equals -1. So I'm going to put those on my graph right away, 5 and 3. So it has to go through those. Now let's take a look at the end behavior, what we just talked about. Well, this equation will have a total power of x to the third. Now yes, there'll be lots of other numbers in this polynomial if you multiply it all out, but the biggest power is going to be x to the third, which means I'm going to have an arrow going this way, and my other end behavior is going to be going up that way. And now we just sort of have to fill in the waves in the middle. So I'm going to follow from this arrow. I have to go through this point. I'm going to go up. Now here's the tricky part. You don't know how high this goes. And so just go up and make a nice curve back down to our next one. We have to go through this. And you don't know how far down to go, so just go down a little ways. But we do have to start curving up because we have to go through the 5. And as you can see, we are set up just perfectly to meet up with our end behavior arrow, just like that. And so now we have a decent sketch of this polynomial function. We don't know how high or how low each of them go, which is why I don't have any numbers on the y-axis. but that is a good sketch of what this graph would actually look like. All right, let's try one more here to see how this goes. So first, we're going to be putting in our x-intercepts. So this first one is what throws people off sometimes, even though it's the easiest. 0. If that x is 0, that gives us a 0. So we are going to go through the origin. We get, from this one, -4. From this one, we get -2. And from this one, +5. Now let's check our power. What is our end behavior going to be? Well, we have x, 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 and x. That is a total power of x to the 4th. And yes, there is a whole bunch of numbers afterwards, but we don't know what they are. And more importantly, it is negative. So our highest power is to the 4th power. That means our end behavior is going in the same direction. And the negative means we're going to be going down. So one end behavior will be down here, and the other will be down here. So this one's going to be upside down. Now we've got to fill in all the waves in the middle. So this has to come up. We have to go through -4. Then I've got to start curving down so I can go through -2. Back through 0. Now one more time, I don't really know how far high or how far down to go. I'm just sort of estimating. You can sometimes think, well, these 2 points are really far apart, and so this one definitely has to go up a little higher before it starts coming down. And as you can see, we are set up just perfectly to match up with our end behavior. So there is a rough sketch of what that graph would look like. So we're just putting in all the x-intercepts and using end behavior to fill in all the waves to fit nicely. All right, so that is our x-intercepts. It does get a little bit more complicated. If you have double or triple roots, that can also affect the graph. So let me show you what that means. Thankfully, we can start this off the exact same way we would usually with our x-intercepts. So that's going to give us -5. That's going to give us -3, +1, and +3 are all of our x-intercepts. Now the end behavior. So what's our total power of x? So here's where it becomes important that we have double roots. So that's 1. This one counts as 2 more because there's 2 of them. So 1, 2, 3, 4. This one also counts as 2, so 5, 6. So our total power is x to the 6th, and it's positive. So that tells me my end behavior will be going up, and it will be going up. All right, now to fill this in. So as I draw this down, I'm coming down towards that -5. I go through it, and I've got to curve up to the -3. Now here's where things get a little different. Because that's a double root, I'm not going to go straight through it. It hits it and it bounces off of it, just like that. And one way to explain that, you can see that this shape right here is a parabola. And an x squared should make a parabola. And so that's why it bounces instead of going straight through. So I'm going to go down a little ways. Now I got to go back up to the 1. All right, now I'm not going to bounce this time. This one's not a double root, so I'm going to go through it just like always. One way to think about that, x minus 1 is a straight line, and so you need to have a straight line right here, linear. All right, I'm going to go up a little ways, but I got to start curving down to get to this 3. But when I get to this 3, I again have to make a parabola. I have to bounce. So I'm going to hit the 3, make a nice parabola, and then go up. And you can see, because I bounced, that sets me up for my end behavior just perfectly. So that one looks really complicated, but that gives us a decent sketch of what this graph might look like. So double roots, you have to bounce off. All right, triple roots. It's similar. idea. But first, let's put all of our x-intercepts. We have positive 1, we have negative 4, and we have positive 3. Now, what's our total power? Don't forget the negative there. So this x, because it's a triple root, counts as 3. So there's 3 of them. 3, 4, 5. So this is an x to the 5th power. And it's negative. So that means my end behavior will be diagonal from each other. One of them will be going up on top left and bottom right. All right, because that cubic or that odd degree has been flipped. So I've got to start up here. I've got to come down here to the negative 4. Negative 4 is a linear factor, and so we go straight through it. And I come down. Again, I don't know exactly how far to go down, but I'm going to start curving my way up back towards the 1, which is where something weird is going to happen. This is a triple root, and so it needs to look like the parent function for x cubed. So remember, x cubed looks something like that. It flattens out and goes that way. It could also be going backwards like that. But that's the shape I need to do right here. So as I come up, I'm not going to go straight. I'm going to flatten out and then keep going up. So that looks like x cubed. But I have to now curve back down to get to my 3 x-intercept. And this one is a linear factor, so we go straight through it. No funny business on that one. And that, again, sets us up for our end behavior perfectly. You always want to make sure you're coming back to your end behavior because you knew that from the beginning those arrows have to match up. So there's a triple root for us. All right, that's pretty much all there is for graph sketching. Do your end behavior, do your x-intercepts, and if you happen to have a double or a triple root, you do need to take care of that. All right, here is a practice one for you. Draw a sketch of both of those. Make sure on this second one that you do take into account this triple and this double root. Good luck.